Oh, I forgot how good this bike is. Here she is, the beauty, the speed machine. Not really set up like a speed machine. We have quite an interesting setup with the gearing. It is standard sort of derailleur, but it's got an internal hub gear inside with 3 speeds. So you've got the 7 here and the 3 speeds internal. It works. It's not that great. I've had it for a long time. It's about 12 years old or 10 years old, this bike. It's done a hell of a lot of miles. I've been up and down the country on it. I've travelled to London and back a few times. I've cycled from London to Pitlochry in Scotland. So it's had a lot of usage. Chain has not been oiled for some time. Definitely in need of some care. Not the fastest setup as well. I used to have a fairing at the front, and I should really have much narrower, harder tyres on it, but I've got it set up for comfort and touring. Anyway, let's go give it a go. Watch it, Mr. Bird! Okay, so why bother with a recumbent? Well, it's nearly all to do with reducing your frontal area, okay? So, you can reduce your drag, okay? So this all comes down to terminal velocity. So you've probably been taught, if you've been in a normal physics lesson, about a skydiver. Someone is in a plane. Right, Lillian? Someone's in a plane and they jump out the plane, and as they go falling towards the ground, now never mind the fact that they're already flying along this way really, really fast, but if you just look at their vertical velocity alone, they initially will start out jumping out here, the person will, and they won't be moving at all, and as they fall they'll get faster and faster and faster. So if you looked at a velocity time graph for them, right, you'd see their velocity going up like this, but eventually it tails off and goes like this. Now why is that? It's because as they fall they've got gravity pulling them down. Okay, I'm going to do this in a different colour actually. Gravity's pulling down on them, and that's the only force acting on them initially. So when they're at this point here, gravity's pulling them down, but as they get faster and faster and faster, they're pushing through the air is pushing on them, and eventually, after they've been falling for a while, so a little bit further on down here, gravity will still be exactly the same size, but air resistance will have increased a little bit, so that when you add these two forces up, let's just say that was a 10, that was a 5, overall this becomes a 5 downwards, right? So maybe here, right, is when this starts to happen. So we've got less overall force acting down, the resultant force, and so you're getting less acceleration, right? The steeper this line is, the greater the acceleration is. So you can see that it's steepest at the bottom, and then it gets shallower here, shallower again, until it's completely flat and there is no acceleration. By the time they've been falling for some time, the air pushing up on the person, so if the person's here again, the air pushing up on the person will be equal to mg, or gravity pulling down, so you've got air pushing up, so this would be the drag force, let's call it D for drag force, and when D is equal to mg, there is no resultant force, and so you'd have a force down, a force up, and they cancel each other out, and there's no acceleration, and you've reached your terminal velocity. Now, how is that applicable to a bicycle? Well, your terminal velocity, if you're pushing yourself forward with, I don't know, say 500 newtons here, because you've got so much frontal area, available to you, you've got so much area here, you're having to push through the air, you don't have to go that fast in order to have 500 newtons pushing back on you. So this guy here might only have a top speed of 20 miles per hour in that position, whereas if he gets himself down, still pushing forward with only 500 newtons, but in this scenario, all tucked up and with less air resistance, his top speed might be 30 miles per hour. But you get the same person with the same power output pushing themselves forward with the same 500 newtons of force here, and your top speed might be closer to 45 miles per hour. And I can tell you from personal experience that if you put a fairing on a recumbent, that top speed can go up to, on a flat, maybe about 50. Downhill, I've hit a 70 miles an hour on my recumbent. So it's all to do with balancing forces. Okay, excuse me.